Algebra 2, Unit 4, Day 2 notes. Okay, looking back at the Day 1 notes, we have some reminders of what we covered in Day 1. When we're graphing an absolute value inequality, we're looking at dashed lines versus solid lines. So if you have a greater than or less than symbol, it is going to be a dashed line. If it's greater than or equal to, less than or equal to, it's going to be a solid line. Then when we shade, right, if we have a slanted line or a horizontal line, then you're going to look at, you're going to go above if it's greater than or equal to. You're going to go below if it's less than or equal to. Okay, so this would be less than, this would be less than, this one will be greater than, this one would be greater than. If you happen to have a vertical line, then we're talking to the right if we're greater than, and then to the left if we are less than. Okay, so for these, the greens are greater and the reds are less. Okay, so that's just a reminder from what we had in Day 1. Okay, looking at these questions here. They have already graphed the two boundary lines for these two inequalities. They want us to shade the two inequalities, okay, and shade the solution set. All right, so first off, let's think about which of these two equations could be, the inequalities could be this graph here, okay? Well, this is a dashed line. So because it's a dashed line, that's going to be a greater or less than. There's no or equal to, which tells me that we're taking a look at this one right here. So the gray line is this one, this dashed line. Okay, I'll trace it with the dashes. For the greater than or equal to line, that's going to be solid. Okay, let's make it a little bit nicer here, better. Okay, because it's greater than or equal to. All right, so we're going to look at shading the solution to this system. Now, very similar to when we had two lines, not inequalities, but linear equations, we saw that the point that worked on both lines, that satisfied both equations, that was the solution. So here, if we're shading regions, okay, if we're shading regions, we want the solution to be the part that is shaded by both graphs, okay? So I want the gray shading and I want the red shading. Okay, so let's shade these. Well, this gray one says greater than, and if it's greater than, the shading greater than is going to go above, okay? So if we're talking about this gray dashed boundary line, above, okay, if we go above on the, look at the y-axis here, okay? Above on the y-axis would be up here. So this is one region, two regions. Both of these regions are above, okay? They're above my boundary line. Okay, now notice that when we made the second, the green, red one and the gray one, you have a total of 1, 2, 3, 4 regions. So saying greater than or saying less than, you're going to have 2 of the 4 regions shaded. Okay, so now let's look at the red, this guy. This one says greater than or equal to. Okay, greater than or equal to says we're going to go above the red one. Okay, so above the red one would be this region and this region. Okay, so out of those 4 regions that we had, I'll say there's a region, there's a region, there's a region, and there's a region. Okay, out of those 4 regions, there's only one region that was shaded 2 times. That is your solution. So this region right here, that region was shaded in red and in gray. So my solution is going to be that top region. So I can erase these here. Okay. Another reason you definitely want to use pencil when you're doing your math, okay, because the solution is only one region. Okay. All right, this next one. Let's look at the fact that we have a dashed and a solid. Okay, the dashed one, let's use green this time for the dashed. Okay, the dashed line, because it's dashed, it's going to be either less than or greater than. So that means we're going to look at this guy right here. So this is your green inequality. And then let's go with blue for the greater than or equal to. And let's see if we can trace that line just a bit. There we go. All right, so let's look at shading. So remember, we have 1, 2, 3, 4 regions. Which 2 regions are we going to shade? Well, this says y is less than. Okay, less than says we're going to go below. All right, I'm going to put my blue line back in here. See if I can do as decent a job as I did the last time. Pretty close. Okay, so we're going to go, again, we're going to go below for the green because it's less than. So below would be this region and this region. Okay. For the blue, it says greater than or equal to, which means we're going to go above. Okay. So greater than or equal to the blue would be this region and this region. Okay. See the region that was shaded 2 times? That's your solution. So this region down here was great for the green boundary line inequality, but not for the blue. This one here was great for the blue one, but not the green. You needed this one, that whole region. On the third problem that we have here in the middle, I just saw a typo, so I have whited out that negative. I'll have it on the note sheet for you in Google Classroom. I'll have it corrected. Okay, so you won't have this typo, but let's do this with the correct question, which is having a positive 2x minus 4 for the second inequality. All right. Okay. Now both of these boundary lines are solid lines. So that means we can't just look at the symbols here and say, I know which one is which. All right, so let's do this. Let's look at the slopes, or we could look at the y-intercepts. Okay. The y-intercept of positive 2 is right there. The other y-intercept is negative 4, which is down here. So I'm going to go with orange, and I'm going to put orange as the positive 2 y-intercept graph. So we have a solid line with the y-intercept at positive 2. And let's use gray. We'll call positive 2x minus 4. So it has a positive slope, so it's rising to the right. And its y-intercept is down there at negative 4, down here somewhere. Okay. All right. So those are my two boundary lines. Let's look at the shading. Again, we have 1, 2, 3, 4 regions, and each of these inequalities will shade 2 of them. Right? So let's look at the orange one. The orange one says less than or equal to. Okay, so less than is going to be lower. Okay, so again, here's the y-axis. Look at the y-intercept. It's going to be lower. So it's this region. Okay. It's also going to be this little region right in here. For the gray, it says is greater than or equal to. So it's going to be above the gray line, which would be this region and this region. Those are above the gray boundary line. So hopefully you can see that this region here only applies to the gray. This region down here only applies to the orange. But the other region, this region over here, has both gray and orange answers. Okay, it has all the solution points. Every point in this lovely interval here is a solution to both of these graphs, okay, both of these inequalities. Okay, let's look at the example down below. This time they want us to do a graph. Okay, no problem, let's do it. So we are going to look, and let's do the graphing in 3 steps. Okay, things that we need to know. We need to know, is it going to be a solid or dashed line? Second thing is I want to actually graph that boundary line. And the third thing is, am I shading above or below? Okay, so let's use gray on this top guy here. Is it going to be solid or dashed? Well, it says less than, so that tells me it's going to be dashed. It does not say less than or equal to. If it had said both, then we would say it's solid. Okay, so this is going to be a dashed line. Now let's graph the boundary line. So treat it like it's y equals negative 4x plus 5. The plus 5 is your y-intercept, your b. So go up 5 on the y-axis and put your y-intercept right there. Rise over run, so 1, 2, 3. Down 4 and right 1 is a good point. Could do it again. On Alex, you only need to do this for 2 points. But since I don't have the cool Alex graphics and the cool little clicker button, 2, 3, 4. 1, 2, 3, 4, 1. Okay, so we said it's a dashed line, and we are going to dash through those points. Okay. All right, shading. It says less than. So that means everything that is below my boundary line. Okay, so my other inequality, I'm going to use red. Is it solid or dashed? Well, it's greater than or equal to, so that's a solid. Do me a solid. Okay, so the line has a y-intercept of 3 and a rise over run of 2, or 2 over 1. So 1, 2, 3, there's my y-intercept. And now I'm going to use that 2 over 1 slope, rise over run. So 1, 2, 3, there's 3 again. Okay, so rise 2, run 1, rise 2, run 1. Let's go the other way. Okay, again, we said it's a solid line. Okay, and it says greater than or equal to. So greater than the red one. So it would be this interval, and this interval, okay? Those two regions are above the red boundary line, so it's greater than, right? Well, hopefully you can tell that this region down here only has gray in it, so it's not the solution region. This region right here only has red in it, so it's not the solution region. Get it out of there, okay? But this region over here does contain all of the solutions. So like this point's a solution, and that point's a solution, and this point's a solution, and that point's a solution, okay? All those points are solutions. They all lie in this region, okay? So there's a nice little example for you to keep in your notes and to refer back to on this video, okay? Next, we're going to graph the solution of the following systems of inequality, and then we're going to give one coordinate pair from that region, okay? Very simple, okay? That's a very simple step. This thing is to graph the inequalities. So let's graph, let's go with this guy up here first. If we're going to graph him, let's bring him over here. Okay, so we want to get y isolated. Okay, we want y all by itself. So remember we did this last notes. We have to cancel with addition and subtraction that negative 5x. Well, since it's negative, we're going to add 5x to cancel it to 0. Okay, add 5x, add 5x. Those cancel nicely. So I'm left with positive 6y. All we did is add, so I'm going to bring down my inequality symbol. And I've got 18 minus 5x. I want to write this positive 5x first. And I want to write that minus 18 right after. Okay. Last thing I want to do, because I want y isolated, I have to cancel that 6. So I got to divide every term on both sides by 6. So 6 divided by 6 is 1. So that's 1y. Okay. 5 over 6, or 5 divided by 6, is 5/6 x. Minus 18 divided by 6 is a minus 3. Now I divided by a positive number, so I am going to keep my inequality symbol. Right? So that is my orange inequality. Let's graph it. Let's start at the minus 3. So my y-intercept is negative 3. Now let's use rise over run. It's going up to the right because it's positive. Let's rise 1, 2, 3, 4, 5 and run 6 units. Cha-ching. Okay, let's go. Oh, we got room to do another one. Okay, so 1, 2, 3, 4, 5. 1, 2, 3, 4, 5, 6, right just off the graph there. If I wanted to go down from my y-intercept, I go down 5 and I go to the left 6. Okay, it's the same line. Okay, now remember, we had those 3 steps. So before I start drawing anything, I look at my symbol, and my symbol tells me it's going to be a dashed line. Okay, so arrow, now a dashed line. Okay, this is less than. Less than is going to be all of that giant region. Okay, so now in red, let's bring that inequality over here so we can work on it here. Whew. A little shaky. Let's try that again. A little better. Okay, so again, we're going to isolate the y term. We got to cancel the 2y, so we're going to subtract the 2x, we're going to subtract it. Okay, so we've got positive 7y. Okay, all we did is subtract, so we're going to keep our inequality. Negative 14 and minus 2x. I want to put the 2x, which is a minus 2x first, so I can have mx plus b form. And then minus 14 or negative 14, okay, goes there. Final thing I need to do, I'm going to divide by 7, divide by 7, divide by 7. So 7 divided by 7 is 1y. I divided by a positive number, so I'm not going to change my inequality symbol. Negative 2 divided by 7 is negative 2 sevenths. Bring your x down. Minus 14 divided by 7 is minus 2. So let's graph this. Okay, first off, is it going to be solid or dashed? Well, it's greater than or equal to, so it's going to be solid. Okay. Okay, so we're going to start at our y-intercept of minus 2. So we'll go to negative 2. That right there. Cool. Now we're going to rise and run for a negative 2/7 slope. So it's going to go down to the right. So rise negative 2 and run 7. And it should put us right about there. Okay. If I rise positive 2 and I go up there, and then I run 7 to the left, okay, there's a nice third dot or third point for my red line. Okay, the red line is going to be solid. We've already said that. So let us connect the dots and connect them. Let's connect them a little better than that. There we go. Okay, now this says greater than or equal to. So greater than or equal to is going to be above the red boundary line. So this and this are my two regions. Okay, so this region down here is only a solution for the orange inequality. This region up here is only a region that has solutions for the red inequality. But this guy right here, that particular region has both orange solutions and red solutions. So that region is our set of solutions. Now, we're going to answer the last question. Give the coordinates of one point that's in your solution set. So we have to give just one pair of coordinates for that region. So you can pick any point you want. You could pick this point right here, 6, negative 2. You can pick this point right here, 6, 0. You can pick this point over here, 10, 0. You could go 10, 4. Good, buddy. Okay. Doesn't matter. You can pick any of these points you want. I'm going to pick this guy right here. That is, let's go with 9, negative 3. And how do you know that that's a solution point? Well, if this is my x and this is my y, then I could substitute 9 for either of these x's, and I could substitute negative 3 for either of those y's, and I could make both of those inequalities be true if x is 9 and y is negative 3. Okay, how do I know? Because that point lies in my solution region. Okay. Now let's do a couple of word problems. Kayla's fish tank has 14 liters of water in it. Okay, so I'm going to underline some important things. So it has 14 liters of water in it at the beginning. She plans to add 4 liters per minute. Okay. Anytime you see the word per, anytime you have a rate of change, those are 2 great indications that you're going to be working with slope. Okay, So adding 4 per minute means that you're going to have a positive 4 for your slope, or your m in your mx plus b. Okay, now it says until the tank has more than 46 liters. Right? So let's make it an inequality about this. So we start with 14 liters, and then we're adding 4 liters per minute. So we can say that we're going to use m, because if it's per minute, m is going to be my number of minutes. So like if I add water for 2 minutes, well, 4 times 2 tells me that I'm going to be adding a total of 8 liters. So 4 liters the first minute and 4 liters the second minute. Okay, so 4 liters per minute times minutes. And now it says that the result has to be more than 46 liters. So more than, greater than, doesn't say or equal to, 46 liters. And there's my setup. Start with 14, there's your beginning amount, your initial amount. And then you're adding 4, which is your rate of change, which is going to be in front of your variable. And in this case, it was minutes. Okay, so now it says, what are the possible numbers of minutes? We want all the possible minutes that could work. So all you have to do is solve for m. Okay, and that's simple enough for you, I'm sure. We're going to subtract 14. Cancel that nicely. So you got positive 4m greater than 46 minus 14 is 32. Now we're going to divide by 4. Divide by 4. So I've got minutes. My number of minutes must be greater than, because I divided by a positive. I'm not going to change my inequality. We have 32 divided by 4, which is 8. So that just tells me that possible number of minutes, okay, more than 8 minutes. Okay. So if we want more than 46 liters, all you know is that Kayla has to put water in for more than 8 minutes. We've answered the question. Okay, now let's look down here to the multi-step inequality. Linda drives a truck. Good for Linda. For a soft drink company. The truck is filled with 15-ounce cans and 70-ounce bottles. So 15-ounce cans, 70-ounce bottles. So I'm going to differentiate between them. Let C be the number of the cans that the truck is carrying, and let B be the number of 70-ounce bottles. So you have B bottles and C cans. Very unique. And now the truck must be carrying less than 6,000 pounds, which is 96,000 ounces. The reason they gave you the ounces is that they've given you everything else in ounces. So that means we're going to be looking at the 96,000. We're going to use the ounces. Using the values and the variables given, write an inequality describing this. So in words, what are we looking for? We're looking for, okay, now this is how many ounces a truck can carry. So why would a truck have a maximum number of ounces that they could carry, or a maximum number of pounds? Maybe if they're carrying too much, maybe it's just a law. One reason is it could be against the law to have more than 96,000 ounces. Reason number 2, maybe they have found that when you have more than 96,000 ounces, maybe your truck is driving across the country, maybe, just maybe, it causes harm to the engine. Maybe it causes air to go out of the tires, okay? It's probably a safety-related regulation, Okay, so whatever the reason is that they want to regulate how many ounces that they carry in their trucks, we now can say that, okay, what do we carry? We carry cans. So the total ounces in the cans plus the total ounces in the bottles, okay? So the total ounces, and the symbol, well, the abbreviation for ounces is OZ. See, the ounces of cans plus the total ounces, that's another OZ, of bottles, has to be less than 96,000 ounces. So how do we express the number of ounces in the cans? Well, one can is 15 ounces. And you just want to know how many cans there are. Well, it says C is going to be the number of cans. So 15 times C tells you how many total ounces of cans that truck's going to be carrying. Okay. Then if you look, it says let B be the number of bottles. So we got how many ounces in one bottle? 70 ounces. There we go. 70-ounce bottle times B bottles. Okay. 70 ounces in one bottle times however many bottles there are. So if we add the ounces of cans plus the ounces of bottles together, they must, because of safety or whatever the reason is, must add up to less than 96,000 ounces. Okay. That is a nice inequality that, it just asked us to write it, didn't ask us to solve anything. Okay, so this is my inequality, and it does relate the cans, the bottles, and the total weight in ounces that you have to have. Okay. Our final page is an example of putting together a big word problem, right, that would involve inequalities. So let's just look at the question and see how they got this answer. Right? Let's see how they got the answer. It's a nice graph, by the way. My kudos to whoever did the graph. So a weekly exercise program. And the weekly exercise program consists of cardio and weights. It's a pretty sound program. Okay, it says let X represent number of hours for cardio. It says let Y represent number of hours doing the weight training. Okay. Okay, so you have your variables. Your variables are set. They are defined. So X is cardio, Y is weight training. So from that, now that we've defined our variables, now we figure out how we are going to set up all of the constraints, the things that we need to do, the things that we can't do more of, okay? And this is very real life right here, okay? So let's look, let's go with gray. First thing is you want to exercise for at least 6 hours. So that means that your cardio plus your weight training has got to be at least 6. So cardio, which is X, plus your weight training, which it says is Y, must be at least 6. So at least, what inequality symbol goes with at least? Well, let's say that you are pricing sneakers and you say, the kind of sneakers I want, I have to pay at least $100. If you say at least $100, does that mean it could be greater than or less than? Okay, if I say I'm going to pay at least $100, could I pay 80? Well, no, that's not at least. Okay, could I pay 100 on the dot? Yes. So at least can be written as greater than or equal to, right? So x plus y is greater than or equal to 6. And by the way, if we solve for the y and we subtract the x, okay, we would see that that would be this guy right here, right? And they would shade, because it's greater than or equal to, they would shade everything above, okay? So I'm just gonna put the gray back. Nice. Okay, next one we're gonna look at, let's go black on this one. Because of maybe you don't want to pull a muscle, maybe you only have a certain amount of time in the weight room, you can do at most 4 hours of weight training. Okay, so your weight training, which we said is y, is at most 4 hours. At most. Okay. So we go back to the sneakers example, and your parent says, I am going to give you at most $100 to spend on your sneakers. Does that mean that they might give you more? If they say, I'm going to give you at most 100. No, it means that's as high as they're going. If it's less, they'll give it to you. If it's equal to, they'll give it to you. But if it's more, not going to happen. Okay? So less than or equal to is how we would symbolically write at most. Oh, wow, looks like a little face. That's cool. All right, so at most is less than or equal to. Y is less than or equal to 4. Well, check this out. Y equals 4 is this boundary line. And then less than would shade here, okay? Notice that the part that is the solution would be part of that still, okay? And then finally, they have one more sentence. And that sentence says, you plan to spend at most 8 hours of cardio. Okay, again, maybe you don't have time to run more or bike more or do the elliptical or whatever you do for your cardio. But at most, 8 hours of cardio. So cardio is X. We just said at most is less than or equal to. And that's going to be 8. So the boundary line of X equals 8. Right, X equals, it's got to be Hoy-Bucks, it's going to be a vertical line. So it's going to be this guy right here. And we said it's less than this. So less than the vertical means you got to go to the left. So that would be all of that. And again, you can see that that solution is going to be in my region of shading for the red. Okay? Now, those are 3 boundary lines that you can pick up and you can make from the problem. But notice they've got a couple more here. This is kind of important. They've got this one on the y-axis darkened in, and they've got this one on the x-axis darkened in. Well, why is that? Well, in real life, okay, if I say less than 4, is -7 less than 4? Sure it is. But can you lift weights for -7 hours? No. So my y has got to be greater than or equal to 0, right? So we could put it there, or you could go back, check this out, right back where we were, and you could have done this, okay? I'm going to stay with adding the extra one because there's an extra line here. So y, the number of hours of weight training, can't be negative. It's got to be greater than or equal to 0. So y equals is a horizontal line, and the horizontal axis, which is the x-axis, this is y equals 0. So if it's greater than 0, then that would be all of this above, okay, which the solution area, the solution region, okay, is part of it. And then last but not least, for the number of hours for cardio, again, you can't have negative hours of cardio. You could have 0, okay, you can have greater than 0, but there is a boundary line, so real life boundary, and if it's x equals, it's going to be a vertical line, okay, and it says greater than or equal to, so that means to the right of it. So that would shade all of that, which again does include, it does include this right here. Okay, so if you take all of the regions that were shaded, all the colors, the gray, the green, the black, the red, and the orange, then the only part that is shaded by everything is the little guy down there that happens to be shaded at the very beginning. Okay, that's why this is your solution. Okay, now something that's cool is, it says give 3 examples of your real life situation of how many hours you would spend doing cardio and how many hours would you do the weight training. All you need to do is find 3 points that are in that region. Okay, so let's pick a point that's right like in the middle of it. So that is the point 6, 2. Okay, 6, 2. So 6 is my x, so that means I could go 6 hours of cardio and 2 hours of weight training. Okay, so if I do 6 hours plus 2 hours, that is more than 6 hours that you would be exercising. Okay, greater than or equal to 6. The y is greater than, the x is less than 8, and the y is less than 4. Okay, so all of the conditions are set. Let's pick another point. Let's go, let's go to this group here. This one. Let's take, let's go with this point right here. Let's see that. That's the point 4, 3. So 4 is my x, which would be 4 hours of cardio. And then 3 was my y, so 3 hours of weights. Okay, and then finally, because they are solid lines, which means that they are including all the points that are on the lines, I'm going to go for this point right here on the corner. Okay, and that's the point 8, 4. So if I really want to do it up, I could do 8 hours of cardio, because 8 is less than or equal to 8. It's the equal to part. And I can do 4 hours, because it's 8, 4, 4 hours of weight training. And 4 is less than or equal to 4. Obviously, 8 plus 4 is greater than 6, so I will have taken my goal and reached it for a number of hours that I'm exercising. Okay, I think my brain is exercised right about now. That is day 2 of Unit 4 in the books. Hope you got something out of it. See ya.